Inside the IBM Cloud outage, why control plane failures are the new enterprise risk frontier. On June 2nd, 2025, IBM Cloud experienced a login failure that rapidly escalated into a multi-region disruption. While the infrastructure itself remained largely intact, users across industries lost access to the IBM Cloud platform's control plane, including administrative dashboards, orchestration tools, and service consoles. This wasn't a catastrophic outage in the traditional sense. No data loss, no compute crash. But it was arguably more unsettling. The platform's very nervous system, its ability to grant access and coordinate action, was momentarily paralyzed. IBM's official communication, issued the following day, acknowledged the incident and described it as a cascading control failure triggered by delayed login responses in a single region. Those delays activated automated health checks and retry mechanisms, which in turn caused a surge in traffic. That surge was rapidly rebalanced across regions. Ironically, by the platform's own resilience mechanisms, ultimately overwhelming control systems on a global scale. While services initially continued for authenticated users, token expiry soon kicked in. As tokens lapsed and could not be refreshed, more users lost access. What began as a routine availability blip became a chain reaction of access denials that spread far beyond the original fault domain. IBM's own incident reports confirm this sequence. A login delay at 9:05 a.m. Universal Time, coordinated on June 2nd, triggered widespread IAM and console failures. By late evening, after nearly 14 hours of user access disruption, IBM had restored logins and control plane functions. The recovery required throttling retry traffic, isolating core services, and rebalancing platform load, confirming this was not a simple auth bug, but a full-blown control plane collapse. Perhaps the most telling part of IBM's response was the admission that full recovery required manual resolution of interdependent service components. The platform had to temporarily isolate core functions from the network to stabilize itself. This speaks volumes about the inherent complexity of distributed cloud systems. Even with automation in place, human hands were needed to untangle the logic and restore normalcy. IBM was quick to emphasize that no security breach had occurred. It also highlighted new global rate limiting and additional monitoring measures to prevent future overloads. Yet for enterprise CIOs, the incident raised a deeper and more unsettling question. If a login delay in one region can ripple through the entire control fabric of a global cloud platform, how resilient is that fabric really? This incident marked IBM Cloud's second platform-level disruption in as many weeks. And while the provider's transparency post-incident was commendable, the pattern is harder to ignore. Login and control plane issues are no longer peripheral hiccups. They are existential risks to operational continuity. This is not just a vendor-specific problem. It's a systemic fragility that modern digital enterprises can no longer afford to ignore. Update: the second IBM Cloud login incident was reported on June 5th, 2025, just days after the first. The authentication outage began at 9:03 a.m. Universal Time Coordinated and lasted over 4 hours, concluding at 1:20 p.m. Universal Time Coordinated. While details remain sparse, the recurrence of access layer disruption in such close proximity has amplified concerns among enterprise technology leaders about underlying architectural stability in IBM's control systems. According to IBM's status page and external reporting, the June 5th outage affected at least 54 IBM Cloud services, including VPC, DNS, IAM, monitoring, and the support portal. While narrower in duration than the earlier June 2nd incident, the breadth of services impacted and the repetition of control plane failures have escalated CIO concerns about systemic architectural exposure and insufficient blast radius containment. Greyhound standpoint. At Greyhound Research, we believe this incident is a wake-up call that forces CIOs to confront a long-standing blind spot in cloud architecture planning. Enterprises have spent years building resilience around data and compute layers, yet many still assume platform access and orchestration will just work. The IBM Cloud outage showed otherwise. As cloud control planes grow more complex and more critical, their failure becomes not just a technical issue, but an operational choke point. Going forward, CIOs must treat control plane resilience with the same seriousness once reserved for data integrity and availability. If your team can't log in, they can't recover. That's no longer an edge case. It's a design imperative. According to Greyhound Research, when platform incidents recur within the same control plane function, particularly authentication, it often signals that resolution efforts are focused on symptoms, not system-wide root causes. In the case of IBM Cloud, the repetition across 2 outages within weeks, both centered on login access, points to a likely shared infrastructure dependency, such as a centralized DNS resolution layer, global identity gateway, or misconfigured orchestration controller. The architectural concern here is not about uptime in the data layer, but operational fragility in the invisible scaffolding that governs access, observability, and orchestration. What amplifies enterprise concern is not just the recurrence itself, but the lack of clarity around architectural containment, whether blast radius boundaries were redefined or if dependency chains were decoupled post-incident. Incident response, no matter how timely, cannot substitute for architectural foresight. And when even core functions like support case access become unreachable during outages, as seen in IBM's own advisory limitations, it raises deeper questions about how cloud providers design for control plane resilience. These events are a caution against assuming that scalability equals fault tolerance. Important to note, both outages left customers unable to access the support portal, file cases, or manage basic platform functions. These cascading disruptions, repeating across core services and locking out governance channels, underline that the control plane is no longer just a technical abstraction. It is the backbone of enterprise confidence. IBM isn't alone. Control plane fragility is a cloud-wide concern. To treat the IBM Cloud outage as an isolated failure would be both convenient and dangerously short-sighted. In reality, this event is just the latest in a growing list of hyperscaler disruptions that have exposed an uncomfortable truth. While cloud infrastructure has matured, the control plane remains a systemic vulnerability across providers. Over the past 2 years, Microsoft Azure, Amazon Web Services, Google Cloud, and Oracle Cloud have all experienced major access layer disruptions. These outages rarely involved full-blown infrastructure collapses. Instead, they followed a more insidious pattern. The workloads were technically fine, but users couldn't log in, push code, access dashboards, or respond to incidents. In other words, enterprises were locked out of their own environments, not because the systems were offline, but because the orchestration fabric was momentarily broken. In March 2024, Microsoft faced a high-profile outage of Azure Active Directory, leaving users across Microsoft 365, Azure, and Power Platform unable to authenticate. Admin consoles were inaccessible, leaving DevOps teams and security operations effectively blind. Late in 2023, AWS suffered a permissions propagation issue within its identity and access management (IAM) layer. While core infrastructure continued running, engineers were unable to launch or terminate instances, apply security policies, or access logging tools. Google Cloud has seen its own share of console-level issues, including a DNS misconfiguration that disrupted access to its cloud monitoring and admin interface. And Oracle's cloud control services, particularly in its managed Fusion apps, have at times faltered under cross-regional load balancing, causing platform-level freezes without any actual infrastructure failure. These incidents confirm that control plane disruptions now cut across providers and geographies, often without clear SLAs or root cause transparency. These events aren't rare anymore. They represent a growing design flaw, a centralized control plane that governs globally distributed systems but without adequate fail-safes or regional isolation. For modern digital enterprises, the implications are enormous. When orchestration tools go down, even briefly, code pipelines stall, monitoring breaks, automation fails silently, and internal incident response slows. And most critically, the ability to prove regulatory compliance in real time disappears. According to Greyhound CIO Pulse 2025, 67% of global CIOs now cite control plane visibility and fault isolation as top-tier decision criteria when evaluating public cloud platforms. In regulated verticals like banking, pharma, and telecom, that number rises sharply. What once lived in the fine print of cloud SLAs is now front and center in board-level risk discussions. Enterprises no longer trust that high availability for infrastructure means operational continuity for their teams, and they're right not to. In a recent Greyhound field note, a global CIO shared how their teams were locked out of orchestration dashboards during a cloud provider's access disruption. The workloads were running. Customers saw no visible outage. But inside the company, engineers couldn't push updates, troubleshoot incidents, or verify telemetry. What struck the CIO wasn't the length of the outage, it was the helplessness. The infrastructure was up, but the organization was over-centralized. Greyhound standpoint. At Greyhound Research, we believe this isn't just a pattern of isolated cloud hiccups. It's a warning about the fragility of access layer services that most enterprises still take for granted. Across hyperscalers, the control plane remains over-centralized, often globally shared, and architecturally fragile under stress. While enterprises have made massive advances in workload portability, observability, and hybrid deployments, their ability to steer and govern these environments is still tethered to a thin operational thread. That thread frays quickly when login systems, token services, or dashboards go down. This incident, and others like it, challenge the illusion of resilience. Uptime is no longer the gold standard. Access, governance, and coordination now define operational continuity, and cloud providers will need to prove their platforms can deliver all three, even when the system is under strain. Why even brief cloud platform outages disrupt enterprise operations? On paper, a login delay or control console outage may not seem like a big deal. The workloads are running. The infrastructure hasn't failed. The status page might even say all green. But from the inside, the picture looks very different. For most digital enterprises, the moment platform access falters, even briefly, coordination unravels, decisions stall, and confidence takes a hit. We've reached a point where cloud platforms are no longer just background infrastructure. They are day-to-day operational scaffolding. Developers rely on seamless access to deploy code. Security teams depend on real-time telemetry. Support engineers need dashboards and logs to troubleshoot in-flight issues. Automation jobs require valid tokens and responsive APIs. When any part of that chain is disrupted, even for 20 minutes, the effect cascades across people, processes, and priorities. The June IBM Cloud outage was a case in point. What began as delayed responses to login requests quickly turned into an operational choke. Many services continued to run initially, but as user tokens began to expire, more teams found themselves unable to authenticate, deploy, or respond. This wasn't a compute-level failure. It was a coordination-level disruption, and that for modern enterprises is often more damaging. In earlier generations of IT, operations teams had the luxury of time and redundancy. A few hours of access delay could be absorbed. But today's businesses operate on just-in-time orchestration. CI/CD pipelines are continuous. Customer-facing features ship multiple times a day. Backend updates are rolled out in tight windows between global market hours. Even a 15-minute outage during one of these windows can derail a release, cause SLA breaches, or delay regulatory filings. This pattern mirrors similar downtime in disguise seen at other firms during recent hyperscaler disruptions, where operations continue, but access to steer those operations vanishes. In a recent Greyhound field note, a global consumer goods company described how a 2-hour console outage disrupted fulfillment coordination across APAC and EMEA. Backend systems were technically operational, but business users couldn't access real-time inventory dashboards, trigger automated restocking workflows, or update regional managers. The fallout wasn't data loss. It was decision latency, and it cost them an entire day of execution at quarter end. This is the hidden danger of access layer fragility. It's rarely visible in traditional metrics. Service uptime dashboards may show 99.99%, but the lived experience tells a different story of users refreshing pages, API requests timing out, and internal Slack channels filling with messages like, "Is the cloud console down for everyone else too?" According to Greyhound Research, recurring access-related outages, however short-lived, trigger a disproportionate governance and risk response within regulated and uptime-sensitive sectors. Industries such as banking, healthcare, and energy operate within tightly bound regulatory and SLA environments, where even transient disruptions to platform control can set off internal compliance alerts, stakeholder escalations, or forced reassessments of cloud posture. These enterprises aren't just evaluating the immediate impact of a login failure. They're accounting for the downstream loss of control, inability to issue fixes, or delayed observability during moments that demand rapid action. The concern is particularly acute when orchestration, backup scheduling, or service desk operations are tethered to a single access layer. In such cases, access denial becomes risk amplification. As cloud adoption deepens in these sectors, CIOs are shifting from measuring resilience by infrastructure uptime to measuring it by business responsiveness. A cloud platform that fails to offer fault-tolerant access mechanisms, especially for mission-critical operations, is no longer just a service provider. It becomes a business continuity risk in itself. That reputational transition is hard to reverse. According to Greyhound CIO Pulse 2025, 64% of digital native enterprises now track cloud platform health, not just through SLA uptime, but through operational fluidity metrics. Login latency, token refresh reliability, and console response times have become central to how IT teams assess daily usability. Among those surveyed, 41% now include these access metrics in their weekly cloud health dashboards. It's no longer enough for the infrastructure to be up. It must be usable, observable, and responsive at all times. And yet, many enterprises still treat platform access as a given. It's rarely tested under load. It's seldom backed up with alternate workflows. And it's often bundled invisibly into vendor SLAs that provide little to no compensation when these control plane slowdowns occur. Greyhound standpoint. At Greyhound Research, we believe the time has come for CIOs to formally reclassify cloud platform access as a mission-critical service, not just a technical dependency. If DevOps can't push updates, if security can't verify logs, if operations can't see system health, then the business is flying blind, even if the data is still flowing. Outages like the one IBM experienced in June are no longer edge cases. They are stress tests. And increasingly, enterprises are failing them not because their infrastructure is weak, but because their access assumptions are outdated. Multi-region outages signal control plane fragility, not just login issues. For years, cloud providers have assured enterprises that regional independence is a given. Zones are fault-isolated. Services are distributed. Failures are localized. But the IBM Cloud outage in June 2025 punctured that illusion. What began as a delayed login response in a single region spiraled into a multi-region failure that affected platform access across geographies. This wasn't an authentication bug. It was a control plane fragility issue, one that turned localized friction into a global paralysis. The core problem wasn't the infrastructure. It was the shared backend logic. Automated retries kicked in after the initial delays, which triggered a spike in traffic. IBM's resilience logic responded exactly as it was designed to, by rebalancing traffic across other regions. But that rebalancing turned into a distributed denial of service against the provider's own control fabric. In essence, the platform's defense mechanisms became the attack vector. This is not unique to IBM. Multi-region impact has occurred across other hyperscalers as well, especially when core services like identity management, DNS resolution, or telemetry pipelines are globally orchestrated but lack robust regional insulation. The idea that the cloud is inherently resilient because it's distributed needs to be re-examined. Distributed systems still depend on centralized logic, and that logic is often the first to fail under compound stress. From a CIO standpoint, the multi-region blast radius of these control plane incidents creates a new kind of risk. It's not just about local failover anymore. It's about architectural entanglement. If authentication services in one region can trigger load failures in another, how isolated are those regions really? And if console access, monitoring dashboards, or orchestration APIs are globally shared services, then regional redundancy is theoretical at best. These aren't just architectural flaws, they are operational liabilities. When control services like IAM, DNS, and orchestration pipelines share global logic, a local issue can trigger a cascading platform freeze. The IBM incident demonstrated exactly this. Such cases are now classified as control plane entanglements, where resilience claims break under scrutiny. Greyhound CIO Pulse 2025 reveals that 62% of global CIOs are now explicitly probing their cloud vendors for control plane design clarity, particularly around failure domains, service segmentation, and dependency maps. In regulated industries such as banking and telecom, 37% have gone further, requesting formal documentation of control plane boundaries and recovery procedures during RFP and renewal cycles. The concern here isn't academic. In another Greyhound field note, a multinational bank reported that a prior cloud incident had rendered its orchestration dashboards inaccessible worldwide, even though core infrastructure and customer-facing services were unaffected. The outcome was far from benign. Internal audit reporting was delayed, scheduled automation jobs failed to trigger, and incident response teams were forced into manual escalation processes. The CIO's takeaway was blunt. Their provider had sold them the illusion of geographic resilience, but the control layer was a single point of global failure. This is the new reality for enterprises operating across multiple regions. High availability can't just apply to the data path. It must extend to the control path. That means decoupling services, isolating token systems, segmenting telemetry, and demanding true regional autonomy, not just for compute and storage, but for access, governance, and coordination. According to Greyhound Research, the recent IBM Cloud outages are part of a broader pattern of modern cloud dependencies being over-consolidated, underobserved, and poorly decoupled. Most enterprises and regulators tend to scrutinize cloud strategies through the lens of data sovereignty, compute availability, and regional storage compliance. It is often the non-data plane services identity resolution, DNS routing, orchestration control that introduce systemic exposure. These components are frequently global in design, centralized across fault domains, and not transparently declared in vendor SLAs or architecture briefs. The real systemic risk is this: a well-configured, secure workload can still become inaccessible or unmanageable if its supporting control logic fails. This blind spot is not unique to IBM. Similar disruptions across other hyperscalers, ranging from IAM outages at Google Cloud to DNS failures at Azure, illustrate the same lesson. Resilience must include architectural clarity and blast radius discipline for every layer that enables platform operability. Until enterprises and regulators begin demanding transparency and optionality at the orchestration and identity layers, control plane failures will remain both more likely and more opaque than many anticipate. Greyhound standpoint. At Greyhound Research, we believe multi-region control plane disruptions are a strategic blind spot in most enterprise risk models. CIOs can no longer assume that regional availability zones offer true fault isolation if their access, orchestration, and visibility tools are still globally entangled. What's needed is a shift in mindset, from protecting infrastructure to governing the governance layer itself. The next wave of cloud maturity won't be defined by how fast workloads scale, but by how well platforms can segment failure. Because when the control plane falls, it doesn't matter where your data lives. If you can't reach it, you're already offline. How enterprises can improve cloud resilience beyond vendor contracts. Every cloud outage sparks the same immediate response. Check the SLA, call the account manager, and escalate to vendor support. But by the time the incident is underway, those moves are little more than damage control. Real resilience isn't built during an outage. It's designed into the architecture long before one happens. And increasingly, CIOs are realizing that true resilience doesn't come from what vendors promise. It comes from what enterprises build for themselves. Most organizations have spent the last decade investing in workload portability, high availability zones, and backup storage. But very few have extended the same level of redundancy to their access and orchestration layers. The assumption is that if the cloud console is down, you wait. If monitoring is unavailable, you fly blind. And if token refresh fails, you ride it out. That mindset no longer holds. The enterprises that fared best during the IBM Cloud outage and other similar events were not the ones with premium support tiers or tighter SLAs. They were the ones that had invested in dual control designs. These organizations had already begun decoupling their orchestration workflows and observability tooling from the primary cloud console. Admin access was available through secondary paths. Telemetry was mirrored into separate regions or even third-party platforms. Internal runbooks included fallback procedures that didn't require real-time console access. And critically, identity and access services were layered, so a single point of failure wouldn't lock everyone out. In one Greyhound field note, a global logistics provider working with our team had recently implemented an alternate cloud access stack as part of a resilience initiative. When a subsequent outage affected their provider's control plane, the company's IT operations maintained visibility and actionability through these secondary monitoring layers. Automation jobs were delayed, yes, but not abandoned. Incident response continued. No major disruption was reported to end users or customers. What began as a resilience pilot is now being standardized across their entire cloud estate. This is the model CIOs must now aim for. It goes beyond multi-cloud and hybrid cloud strategies. It's about multi-layered operational resilience, where core functions like observability, orchestration, and access don't rely on a single vendor console to function. It might mean hosting a lightweight admin interface outside the primary provider, or mirroring your telemetry into an isolated observability plane, or deploying fallback DNS and routing logic so that internal systems can still talk, even if the cloud console can't. Greyhound CIO Pulse 2025 confirms that this shift is already underway. 56% of global enterprises with digital operations across 3 or more regions have begun separating their workload automation from the native provider consoles. And 34% have added contract clauses requiring control plane visibility, architecture reviews, and fault domain transparency as part of their ongoing cloud governance. These numbers are only going to rise, because after every outage, another CIO has the same realization. Waiting for your vendor to bring you back online is no longer a strategy. It's a liability. Greyhound standpoint. We at Greyhound Research recommend designing fallback access portals, hosting telemetry in third-party observability stacks, and conducting quarterly architecture reviews with cloud providers. These practices are fast becoming standard for digital native organizations that cannot afford console downtime to paralyze DevOps or compliance workflows. At Greyhound Research, we believe that modern cloud resilience is no longer just about data backup or compute redundancy. It's about rethinking how enterprises architect for access continuity, control autonomy, and operational visibility, especially when the vendor console is unavailable. The organizations that will lead in this next phase of cloud maturity are not those who buy resilience off the shelf, but those who design it into their own architecture, layer by layer. Cloud vendors may offer platforms, but resilience? That's still a DIY job. DNS-related failures are a canary in the cloud resilience mine. If login failures are the visible symptoms of control plane fragility, then DNS disruptions are the quiet, systemic warning signs. They don't always make headlines, and often they're buried under vague root cause reports. But when DNS systems misfire, especially those tightly coupled to login, service discovery, or internal routing, the results can be just as debilitating as a full-scale outage. In fact, they're often worse, subtle enough to evade immediate detection, yet widespread enough to stall entire business functions. DNS is foundational to how cloud services operate. It governs how internal services find each other, how users authenticate, and how workloads are orchestrated. And yet, in most cloud environments, DNS resolution remains highly centralized, a globally shared layer with few buffers between regions, tenants, or service classes. The assumption has long been that DNS is stable, invisible, and abstracted away. But incidents over the past 2 years have shown otherwise. At least 3 of the top 4 global cloud providers have experienced internal DNS-related slowdowns or misconfigurations that disrupted access to consoles, API endpoints, or internal routing paths. These weren't cybersecurity incidents. They weren't tied to data center failures or overloaded compute. There were small misalignments in name resolution, cascading into major visibility and control losses. Public cloud DNS failures have disrupted control services across Google Cloud and Oracle Cloud in recent quarters. In May 2025, an Oracle DNS misalignment in its Germany region triggered console outages. In earlier Google Cloud events, DNS misconfigurations blocked access to GCP's telemetry tools. These incidents point to an emerging trend. Even minor control layer timing issues can cripple observability and automation systems at scale. In one such incident observed by Greyhound Research, a regional DNS delay in a cloud provider's Asia-Pacific region created a temporary disconnect between the orchestration layer and telemetry services. Engineers could not confirm whether automation jobs had completed because monitoring agents could not resolve endpoint paths in time. The incident didn't trigger any SLA violations, but it did prompt a multi-week review of internal dependencies that the CIO later described as long overdue. What makes DNS failures especially dangerous is that they affect the very services enterprises depend on during outages: monitoring tools, access interfaces, service discovery protocols, and observability frameworks. If DNS is down or degraded, fallback mechanisms often fail silently, masking the root cause and wasting critical response time. The irony is brutal. The tools built to track system health are among the first to become blind. Greyhound CIO Pulse 2025 shows a rising awareness of this problem. 44% of enterprise IT leaders now include DNS isolation metrics in their cloud architecture reviews. In latency-sensitive sectors like energy, healthcare, and logistics, where workload timing correlates with safety, compliance, or asset synchronization, regional DNS resolvers are becoming a standard architecture requirement, not just a best practice. This trend is particularly strong in Asia-Pacific and Northern Europe, where sovereign cloud mandates are pushing providers and clients alike to rethink platform locality, not just in terms of data, but also for the access and coordination layers that support it. Enterprises in these regions are beginning to ask tougher questions. What happens when a DNS node fails? Is our authentication tied to a single resolution path? Are internal services resilient to naming delays? Or is everything routed through a single cloud-provided resolver? In a recent Greyhound field note, a global energy conglomerate described how a DNS hiccup delayed orchestration triggers across both refinery systems and renewable asset controls. While workloads didn't go offline, the timing of jobs was affected, which in regulated environments translated into operational risk. The CIO summarized it bluntly: "We assumed DNS was just plumbing. Turns out, it's a load-bearing wall." Greyhound standpoint. At Greyhound Research, we believe DNS and other internal resolution systems are the unsung linchpins of cloud resilience. Too many enterprises treat them as abstracted, low-risk layers until something breaks and no one can explain why services can't find each other. As cloud workloads scale across geographies and time zones, the fragility of shared coordination services becomes an enterprise-scale liability. Resilience now means designing architectures where services can continue to communicate and self-heal, even when the naming layer itself is unwell. Enterprise CIO Playbook, 10 points to ponder. Not every outage leaves behind a wake of broken systems. Some leave behind something harder to fix, shaken trust. The June 2025 IBM Cloud incident and similar control plane failures across hyperscalers have underscored a critical truth. For enterprises, cloud resilience is no longer just about whether your data is safe or your compute is running. It's about whether your teams can access, observe, and govern the systems they rely on, even when the platform is under stress. For CIOs and other enterprise leaders, this moment demands more than a technical fix. It requires a strategic rethink. The following 10 points are not meant as a checklist to blame. Rather, they're provocations designed to guide internal conversations, challenge inherited assumptions, and recalibrate what good looks like in cloud resilience. First, it's time to accept that uptime is not the same as usability. Infrastructure may be operational, but if your teams can't access consoles, push code, or view telemetry, then your business continuity has already broken down. Second, assume control plane incidents are not rare events, but structural risks. They don't show up as downtime, but they create operational paralysis just the same. Your runbooks should reflect that reality. Third, rethink how you define critical path systems. It's not just your core apps or customer-facing APIs. It's the login screen, the token refresh handler, the DNS resolver, and the console dashboard. These are the first to go dark, and the last to be prioritized in traditional DR plans. Fourth, decentralized control. If your DevOps or security teams rely entirely on a single console, you're creating a coordination choke point. Build fallback access pathways that can operate independently of the vendor's primary control surface. Fifth, elevate login, identity propagation, and dashboard latency into your regular SRE metrics. Many organizations track these reactively after an outage. Mature teams monitor them as frontline indicators of systemic health. Sixth, require architecture-level transparency in vendor conversations. Ask to see control plane fault domains. Challenge providers on how identity, observability, and orchestration are regionally isolated or not. Providers should be able to demonstrate isolation zones, control plane fallback protocols, and access resilient simulations, just as they do for data redundancy. Seventh, separate observability from orchestration. If the same outage takes down both your automation tools and your ability to view what's broken, your recovery time will double. Eighth, revisit the mental model of shared responsibility. Just because a control service is managed by the cloud provider doesn't mean it's outside your resilience plan. If it's a dependency, it's your problem. Ninth, integrate control plane disruption scenarios into your business continuity testing. What happens if no one can log in? If token renewal fails across teams? If the console shows green, but APIs are unresponsive? Run the drill. And 10th, challenge your enterprise on one deceptively simple question. Do we have a plan B if the cloud console is unavailable for 3 hours? If the answer is no, you're not resilient. You're lucky. Greyhound standpoint. At Greyhound Research, we believe the next phase of enterprise cloud maturity will not be defined by how much you move to the cloud, but by how intelligently you assume its limitations. That means planning for the gray zone between uptime and outage, where access is blocked, but systems are still running. In that zone, your architecture matters, your expectations matter, and your leadership's clarity matters most of all. Checklist for cloud vendor accountability. Outages come and go, but contracts tend to linger. And while no cloud provider can guarantee perfect uptime, what CIOs can and must demand is transparency, architectural clarity, and accountability, especially when it comes to the control plane. The days of treating platform access and orchestration tools as out of scope in cloud SLAs are over. For most enterprises, the vendor relationship is still structured around infrastructure guarantees, compute uptime, storage durability, and network latency. These remain essential, but they're no longer sufficient. If your team can't log in, can't view telemetry, or can't execute automation during a disruption, the rest of the platform may as well be offline. Based on recent incidents across multiple cloud providers and the evolving needs surfaced in Greyhound CIO Pulse 2025, here are 10 non-negotiables enterprise leaders should now embed in their vendor accountability frameworks. First, insist on documented control plane fault domains. If the provider claims regional resilience, they must show how access services, like login, orchestration, and monitoring, are geographically isolated. Second, demand SLA coverage that includes console and control plane responsiveness. If the only thing guaranteed is infrastructure uptime, you're missing the layer that governs everything else. Third, ask for visibility into how retries and self-healing mechanisms are architected. In the IBM incident, automated rebalancing became the failure trigger. Understand how your provider contains feedback loops. Fourth, require region-specific telemetry for control services. You shouldn't have to wait for a post-mortem to know whether login latency is spiking in APAC or token refreshes are failing in EMEA. Fifth, formalize incident reporting SLAs for control plane issues. Most vendors escalate storage or compute problems immediately, but access layer slowdowns often sit unnoticed. That delay is expensive. Sixth, push for shared incident testing, especially for console and orchestration failures. If the provider can't simulate a control plane failure and demonstrate recovery time, that's a gap. Seventh, negotiate access to out-of-band interfaces or alternative admin paths. During console outages, enterprises need a way to maintain continuity. If the vendor has no plan for that, build your own and document it together. Eighth, include audit rights for orchestration tooling. If you're relying on vendor-managed automation engines, know how they recover, fail, or escalate when the platform itself is under strain. Ninth, align on joint architecture reviews every quarter, specifically focused on control layer improvements. Make this a standard part of your governance cadence, not a one-time negotiation at renewal. And 10th, include penalties or clawbacks tied to control plane disruptions. If login, monitoring, or token systems go dark, even without full infrastructure impact, there should be recourse beyond a generic credit. Greyhound CIO Pulse 2025 confirms the shift. 61% of enterprise tech leaders now include control plane terms in their cloud contract frameworks. Of those, 39% have already updated vendor evaluation templates to score providers on access continuity, not just data reliability. Greyhound standpoint. At Greyhound Research, we believe vendor accountability in the cloud era must evolve beyond uptime guarantees. Enterprises should be asking tougher questions, not just will the server stay on, but can my team steer the ship when it matters most? Control plane clarity is now table stakes. If a provider cannot explain, isolate, and recover access layer services with confidence, then they have no business calling their platform resilient. Final Greyhound standpoint. Rethinking cloud confidence for the control plane era. Cloud maturity isn't just about how much infrastructure you can move, automate, or scale. It's about how confidently you can operate in the moments that matter, especially when the unexpected happens. The IBM Cloud outage in June 2025 and the string of similar incidents across other hyperscalers have revealed a harsh but necessary truth. The control plane has become the soft underbelly of enterprise resilience. It's no longer sufficient to treat login systems, orchestration consoles, and access APIs as administrative conveniences. They are now operational lifelines. And when they go dark, even briefly, the ripple effect extends far beyond IT. Product launches stall. Security teams lose visibility. Incident response freezes midstream. For organizations running 24/7 digital operations, this isn't a technology gap, it's a business continuity risk. Enterprises can no longer afford to view cloud vendors as infallible platforms, nor cloud contracts as static guarantees of reliability. Today, resilience must be earned, internally through design and externally through accountability. It must be engineered into every layer, not just where data lives, but where decisions happen. Not just in the compute nodes, but in the human workflows they support. At Greyhound Research, we believe CIOs need to make a fundamental shift from measuring cloud confidence by uptime percentages to questioning what happens when access falters. The organizations that lead through this new era will be those that prepare not just for outages, but for those gray zones where the platform is still running but unreachable. Because in those moments, architecture isn't abstract, it's everything. The enterprises that lead through this shift won't be those with the best uptime metrics. They'll be the ones who can act, adapt, and recover, even when the platform is blinking green but behaving red. Analyst in focus, Sanchit Gogia. Sanchit Gogia or SVG as he is popularly known, is a globally recognized technology analyst, innovation strategist, digital consultant, and board advisor. SVG is the chief analyst, founder, and CEO of Greyhound Research, a global, award-winning technology research, advisory, consulting, and education firm. Greyhound Research works closely with global organizations, their CXOs, and the board of directors on technology and digital transformation decisions. SVG is also the founder and CEO of the House of Greyhound, an eclectic venture focusing on interdisciplinary innovation. Copyright policy. All content contained on the Greyhound Research website is protected by copyright law and may not be reproduced, distributed, transmitted, displayed, published, or broadcast without the prior written permission of Greyhound Research or, in the case of third-party materials, the prior written consent of the copyright owner of that content. You may not alter, delete, obscure, or conceal any trademark, copyright, or other notice appearing in any Greyhound Research content. We request our readers not to copy Greyhound Research content and not republish or redistribute them, in whole or partially, via emails or republishing them in any media, including websites, newsletters, or intranets. We understand that you may want to share this content with others, so we've added tools under each content piece that allow you to share the content. If you have any questions, please get in touch with our community relations team at connect@thofker.com.